So this video is to try to take you through Multisim Live. So this is the online version of Multisim, which you should be able to get on your student laptops or on a computer at home, which should allow you to at least keep up with the content if you are not in class to use the actual Multisim. So I've like watched some tutorials on this to try to take you through it, but remember that I am learning how to use this as well. And it does work differently from Multisim. There's a couple things that I thought were better about it, and some that I didn't like at all, and certain adjustments that we'll have to make to the circuits just because they work a little bit differently. So I guess I'll title my circuit something, Winging It Demo, okay, because we're winging it on this. So I'm going to look at activity 116, and I think I'm going to try to do the first and second circuits for you. I'm making a face, and you can't tell that I'm making a face. So when you're building it in Multisim, you have to have your power supply, and you have to have your ground, which I like because that's realistic. It's realistic for you to have like power and ground because that's how you're going to build a circuit. Multisim Live is a little bit different. So this really threw me. So for our power, we can actually do things a little bit differently. I'm going to come down here to this little NAND gate down here, and we're going to pick a digital constant. And see how it says a 1? That literally means like power. And my phone is ringing. Okay, we're back recording. That phone call was about 45 minutes long, just so you guys know. So I don't remember what I was doing. So yeah, in Multisim we have like power and we have ground. In Multisim Live we have this like digital constant, and you'll see that it's set to a 1. That's the same as power. Okay, so 1 is like your 5 volts, it's your power. Now when you place this, I learned this, you can do a couple things. You can turn it so it's facing the direction you want. You can flip it like that, clicking that button there. You can toggle it off, so that's like flipping the switch, so you're going from 1 to 0, and you can copy it, so if you need to have more than one. So for this first one, you could do this where you put 2 of them on there, and then the one that's a 1, you can call that your power, and then the one that's a 0, you can call that your ground. And then you can go ahead and put in your switch. So for Multisim Live, like we have the switch, and I'll do the next one differently, okay? Because technically these will work as switches because you can toggle them. In Multisim, you have your 5 volts, you have your ground, and then you have to put the switch in. But I kind of want to show you both ways to do this, just so that you have some options and you can kind of go back and forth between the two programs. Okay. So consider your power to be the 1 and your ground to be the 0. And then you can click down here on switches, and we want a single pole double throw switch, and we do want to rotate that. Whoa. I think I tried to do a simulation. But make that go away. Okay, let me try that again. Okay, I'll put that there, and then I want to rotate it. There we go. And then we can toggle it by clicking on it. Okay, so there's my switch. Now, this is where I kind of like a feature of Multisim Live better. If you look at Multisim, we have to put these probes in everywhere to see whether like we're high or we're low, and the probes go on, and you can watch the video on Multisim to see if it that's going high or low. Multisim Live, if it does what the demos I've seen do, like it changes the color of the wire, and so like the wire is like light blue if it's high and dark blue if it's low, which means you don't need to put a probe in, which is kind of nice. Now we do need to put an inverter in for part 1. So I'm going to click down here on what looks like the NAND gate. And I want an inverter. Don't confuse it with the buffer. Okay, the buffer is a buffer. And the inverter's got the little circle on the end. And we'll go ahead and place our inverter. Now, this is where I didn't like it. Like we don't want to put like a light bulb in here because like we don't want to mess around with voltage and extra resistance, but we do need to have some kind of indicator at the end. So in Multisim, we can just put a probe at the end to just test and see whether or not our output is high or low. In Multisim Live, we are going to need to use an LED. So you can click on the little lamp thing and we'll pick an LED. And I guess I'm going to turn this, there we go. And we'll move it up a little bit. And then because that's an actual electrical component and not the fictitious probe, you do need to connect it to ground. So up here, schematic connectors, we do need to put ground over here. Now, this is what we were doing in class the other day. When you want to connect them, you kind of need to zoom in and get that little wire spool, and it's easier if you zoom in and do it. So I get my little wire spool and connect my wires. So I connect 1 to power, 1 to ground. We'll go through the inverter. That went the opposite way. Okay, that's very weird. Went the opposite way that I thought it was going to go with my mouse. And connect that. And then okay, connect this. Okay. So now I've got my circuit built. Consider the digital constant 1 to be like power and 0 is ground. And then we have this switch, and I can toggle the switch by just clicking on it. Okay, so let's go ahead and hit the play button up in the upper left, and it should connect a probe to show graph or data. Okay, well, it didn't do the thing with the color wires, which is strange, but that's a bummer. But you can see when you've got the switch toggling, it turns the LED on and off. Let me see if I can connect. It says like connect a probe. Let me try this. I don't know what that is. Digital I/O. Let's put the probe. We might be able to use that instead of an LED. So, okay. All right. Oh, that's kind of cool. Okay, so it's showing a digital low. And then when I click this, it's showing a digital high. All right, like 1. All right, that'll work. You can use that as a probe. And then notice the relationship between the input and the output. So if the input into the inverter is a 0, the output is high or a 1, the LED turns on. When you flick the switch, then the input is a 1 because you're connected to your digital constant 1. It goes through the inverter and the output is low. So when you fill out the table for activity 116, then you've got the table was 0 becomes a 1 and 1 becomes a 0. So here's your 1 becoming a 0. Here's your 0 becoming a 1. And so forth. Then it says in bold, from the analysis of the truth table, why do you think this is called an inverter gate? Like, why does this gate have the name that it has? What do you think this does? Okay, so that's the first circuit in 116. The next one, let's go ahead and I don't know if I can like delete this, or I'll just kind of come down here and yeah, we'll just build the second one on the same page here. So for the second one, it's got 2 switches. So you've got like your 5 volts and your ground, and then you've got two switches, and you could do that the same way that I did this one. You could have your 5 volts, your ground, and then put in two switches. And you can go check out the video on Multisim. I don't know that I did that one. I think I did one further down. I don't remember which one I did, but I think I did one further down. But for this one, we're going to use the fact that our good grief, digital constants can act as switches instead of going through these switches, because we can just toggle our digital constants. I don't know if I said digital ground. It's been a long day. Digital constants. So let's go ahead and try to build that. So let's go to digital. We're going to pick digital constant. And we have, for number 2, 2 switches, and I can copy it. Just hit the copy like so. Okay. So there we go. Now D3 and D4, like that just tells me how many I have on this particular page. Now those are going to be each connected to a probe, and they're going to go through an AND gate, 74LS08N. So you want down here an AND gate right here, and then it gives you all kinds of stuff to pick from. So most of the time we're going to use a 2-input AND gate, but you can pick some other ones. I'll give myself a little bit of space here. And then let's see what we can do with those probes. So let's connect. Oops, there was my little spool. Okay, there we go. So we'll connect 1 to 1, and oh, I gotta click off of that because I don't really know how to use this. All right. Oh, this is gonna do the thing with the wire. And then let's go ahead, and I think we have to do the LED. I don't think it'll let me put a digital probe right there. Maybe it will. Nope, it's out of date. I don't know what that means, but that one says out of date too, so I don't know. All right, let's see what happens. I'm gonna hit the simulation button, and okay, that probe down there at the end isn't doing anything. So that did not work. So I'm gonna go get rid of that. Let's go put the LED in. So we'll do an LED, and then we need ground because you have to connect your LED to ground. I think I can just do the junction like that, and then we'll connect these with a wire. Okay, so let's run the simulation. And this is where you can see like the inputs going in. So it's like a light colored blue, but when I toggle it, it turns dark. So you don't need the probes X and Y on there. I'm not sure why it did it on this one and not on the one above it, like where it just, yeah. And now it's high again, and then low. Now notice what's happening to the LED. So this is like your probe at the end. So if both of the inputs are 0, 0, this would be like the top line in your truth table. 0, 0, the LED is off, which is 0. Then I'm going to take the second probe and turn that on. So the input is 0, 1. And notice that the LED is still off, which is 0. So you're going to have 0, 1, 0. Then we're going to switch them so that the first one is on and the second one is off. That's 1, 0. And I do like how the wiring color changes like that. That's kind of cool. It won't work great for really complicated circuits, but and notice the LED is still off, so that's like 1, 0, and then the output is 0, and then we'll make them both 1, and now notice that the LED is actually on. And so the truth table for that would be like 0, 0, 0, 1, 0, 0, 1, 0, 1, 0, 0, and 1, 1, 1. And then you have from the analysis of truth table, why do you think this is called an AND gate? And make sure that you answer that. To just do, I don't know if like we want to do too much more. I don't know if you can do this whole activity on Multisim Live. Let's go ahead and stop the simulation. That should set you up pretty well to do like the first part of it. For the second one, you've got the same idea there, but for the third one, instead of an AND gate, can I undo that? I was, okay, hoping just to delete not the wires on the, well, whatever. I think you can just delete that. We want to put in a NAND gate. So you got your and then your NAND has the little circle on the end. And then we can go ahead and connect our wires. Maybe, there we go. Connecting our wires. I just haven't used this program. I don't know if it's as good as like regular Multisim, but it's serviceable for sure. Okay, so now if I run this one, let's start them with 0, 0. Okay, 0, 0, so I have 0, 0. Notice that the LED is on this time. So you'd have 0, 0, 1. Then we'd have 0, 1, 0, or 0, 1, and notice that it's still on, so it would be 0, 1, 1. Now we'll switch that to 1, 0, and then it's still on, so 1, 0, 1. And now I'll turn them both to 1, and notice that the LED went off. So anyway, the fourth one, you're going to replace it with an OR gate. The fifth one, you do the same circuit, replace it with a NOR gate. Then you replace it with a XOR gate. Let's make sure we can find a XOR gate. Is there a XOR gate? I don't know. Oh, XOR. There it is, right there. XOR gate. Oh, there are some more things here. So that should take you through part 6. Then when you get to part 7, you need a flip-flop, and fortunately there is a thing for flip-flops and latches. For this one, you want a D flip-flop. So if you're looking at number 7, you want a D flip-flop, and that'll bring up your D flip-flop. Ta-da! It looks like the coding is a little bit different than what is on there. Like you have your D, and they have EN instead of the clock. Okay, just they have the EN instead of the clock, but it should work the same way. And then for 8, that, what is that? That is an LM555CM time oscillator. I don't know if that's on there. Let's see. Nope, that is definitely not it. You can look at the little parts numbers and see. That one might not be on there. The LM555, yeah, that one. So it's a timer. You check binary counters. Nope. We could do a search. LM555. Oh, look at that. LM555CN. Boom. Oh, there it is. There it is. So you've got it. There's no excuses if you're doing this from home. Okay. I've like totally made a mess of that. So you got your flip-flop, and now we know we can go up there and search. So I'm sorry that this video is a little less than polished because I'm winging it. It's a winging it demo with a 45-minute phone call wedged into like the first 2 minutes. So hopefully this does help. And if you are absent and you can't get access to Multisim, this gives you a way of being able to complete the activities and learn the content without falling behind, at least to some extent. And if there are some issues coming up that something isn't in Multisim Live or it just isn't working, we will cross those bridges like if and when we come to it. So hopefully this does help, and yeah, let me know if you have some questions.